Hi, let's go for Cloud Spanner. So we are going to talk about what is Cloud Spanner and what is architecture and some of the interview questions which you required. So let's get started.
GCP, Cloud Spanner. Cloud Spanner is a fully managed, highly available, globally distributed relational database service offered by Google Cloud. It is designed to handle mission-critical transactional workloads at scale, while also providing strong consistency and high availability across multiple regions and zones. Cloud Spanner uses a unique architecture that combines the benefits of traditional relational databases with the scalability and resiliency of NoSQL databases. It provides horizontal scalability, strong consistency, and low latency by using a distributed shared nothing architecture, where each node is independent and communicates with other nodes through a highly optimized distributed transaction protocol. With Cloud Spanner, users can create highly available and globally consistent databases, replicate data across multiple regions, and easily scale their database as their business grows. It is a fully managed service, meaning Google Cloud handles all aspects of database administration, such as backups, replication, and monitoring, allowing users to focus on their applications and business logic. Cloud Spanner supports standard SQL queries, and it is compatible with other Google Cloud services such as App Engine, Kubernetes, and BigQuery. It is commonly used for mission-critical applications that require high scalability, high availability, and strong consistency, such as financial trading platforms, e-commerce, and online gaming. What is Architect Cloud Spanner in GCP? The architecture of Cloud Spanner in Google Cloud Platform, GCP, is designed to provide a highly available, globally distributed, scalable, and strongly consistent relational database service. Cloud Spanner uses a distributed architecture to provide scalability and high availability. The service is composed of multiple nodes, which are organized into groups called zones. Each zone consists of several nodes that work together to provide a highly available and fault-tolerant service. In addition, Cloud Spanner uses a globally distributed architecture that enables it to replicate data across multiple regions, providing low latency access to data and enabling global consistency. Cloud Spanner's distributed architecture also provides automatic failover in the event of a zone outage or network disruption, ensuring that the service remains available and responsive. Cloud Spanner uses a distributed transaction protocol to provide strong consistency across multiple nodes and regions. This protocol ensures that transactions are executed atomically, consistently, and serially, regardless of the number of nodes or regions involved. Cloud Spanner is a fully managed service, which means that Google Cloud handles all aspects of database administration, including backup, replication, and monitoring. Users can focus on their applications and business logic, while Google Cloud takes care of the underlying infrastructure. Overall, Cloud Spanner's architecture provides a highly scalable, available, and consistent relational database service that can be used for mission-critical applications, such as financial trading platforms, e-commerce sites, and online gaming. As you can see from the diagram, Cloud Spanner consists of a client application that communicates with the Cloud Spanner service using either SQL or gRPC API. A Cloud Spanner is a distributed database that consists of multiple nodes organized into zones, which work together to provide a highly available and fault-tolerant service. The Paxos protocol is used to ensure strong consistency and reliability of data across multiple nodes and regions. The Google Cloud infrastructure provides the underlying compute, networking, and storage resources necessary for Cloud Spanner to operate efficiently. Overall, Cloud Spanner's architecture enables it to provide a highly available, globally distributed, and scalable relational database service with strong consistency and low latency. Regenerate response. Here are some potential interview questions related to Cloud Spanner in Google Cloud Platform. What is Cloud Spanner, and how does it differ from other relational databases? How does Cloud Spanner provide strong consistency across multiple nodes and regions? How does Cloud Spanner ensure high availability and fault tolerance? What are some of the key benefits of using Cloud Spanner over other database solutions? How does Cloud Spanner scale horizontally, and what are some best practices for scaling? What is the role of Paxos in Cloud Spanner, and how does it help ensure data consistency? How does Cloud Spanner handle backups, disaster recovery, and replication across multiple regions? What is the pricing model for Cloud Spanner, and how does it compare to other database solutions? How does Cloud Spanner integrate with other Google Cloud Platform services, such as Kubernetes and BigQuery? Can you describe a scenario where Cloud Spanner would be a good fit for a particular application or use case? Cloud Spanner's pricing model is based on several factors, including the amount of data stored, the amount of data transferred between zones and regions, and the number of nodes provisioned. The basic unit of pricing for Cloud Spanner is a node hour, which represents the cost of running a single node for 1 hour. Additional charges are incurred for storage, network egress, and cross-region data transfers. Cloud Spanner offers a regional configuration, where a single database instance can be deployed within a single region, and a multi-region configuration, where a single database instance can be deployed across multiple regions. The multi-region configuration is more expensive due to the additional resources required to provide global consistency and replication. Compared to other database solutions, Cloud Spanner's pricing can be higher due to its advanced features and global scalability. However, Cloud Spanner provides a fully managed service, which means that users don't have to worry about infrastructure management, backups, or scaling. Additionally, Cloud Spanner offers high availability and strong consistency across multiple regions, making it a good fit for applications that require low latency access to data and global consistency. Overall, the pricing for Cloud Spanner is competitive with other high-end database solutions, and it provides significant advantages in terms of scalability, consistency, and reliability. Cloud Spanner is a good fit for applications that require a highly available, globally distributed, and scalable relational database service with strong consistency and low latency. Here are a few scenarios where Cloud Spanner could be a good fit. Financial trading platform. A financial trading platform requires low latency access to data and high reliability to ensure that trades are executed accurately and in a timely manner. Cloud Spanner's globally distributed architecture can provide low latency access to data, and its strong consistency and high availability can ensure that trades are executed accurately and reliably. E-commerce site. An e-commerce site requires a highly scalable and available database to handle a large number of transactions and users. Cloud Spanner's distributed architecture can provide automatic scaling and failover, ensuring that the site remains responsive and available, even during peak traffic periods. Online gaming. An online gaming platform requires low latency access to data, strong consistency, and high availability to provide an immersive and responsive gaming experience. Cloud Spanner's globally distributed architecture can provide low latency access to data, and its strong consistency and high availability can ensure that the gaming experience is consistent and reliable across multiple regions. IoT sensor data. IoT sensor data requires a highly available and scalable database to handle a large volume of data and provide real-time analytics. Cloud Spanner's distributed architecture can provide automatic scaling and failover, ensuring that sensor data is captured and processed in real time, even during peak traffic periods. Overall, Cloud Spanner is a good fit for applications that require a highly scalable, available, and consistent relational database service that can be used for mission-critical applications, such as financial trading platforms, e-commerce sites, online gaming, and IoT sensor data. Here are some of the key benefits of using Cloud Spanner over other database solutions. Global scalability. Cloud Spanner is a globally distributed database service that can scale automatically across multiple regions and continents, providing low latency access to data from anywhere in the world. High availability and reliability. Cloud Spanner is designed to provide high availability and fault tolerance, with built-in replication and automatic failover to ensure that data is always available and consistent. Strong consistency. Cloud Spanner provides strong consistency guarantees across multiple nodes and regions, ensuring that reads and writes are always consistent and up to date. Fully managed service. Cloud Spanner is a fully managed service, meaning that users don't have to worry about infrastructure management, backups, or scaling. This allows developers to focus on building their applications, rather than managing their database infrastructure. SQL-based interface. Cloud Spanner supports a SQL-based interface, which makes it easy for developers to use and integrate with existing applications and tools. Advanced security features. Cloud Spanner provides advanced security features, including data encryption at rest and in transit, identity and access management, IAM, integration, and network isolation. Overall, Cloud Spanner provides significant advantages over other database solutions in terms of global scalability, high availability and reliability, strong consistency, ease of use, and advanced security features. It is an ideal solution for mission-critical applications that require low latency access to data and strong consistency guarantees across multiple regions.
Thank you for watching. So this is the Cloud Spanner. As we talk about Cloud Spanner, so it's the same way as the SQL, but it's in a distributed data manner. So it's basically use the ACID transaction, means there is a theorem for a relational database called ACID. So it follows this principle, and it also has very good horizontal and vertical scaling, and also it supports the SQLs. And if you can, we can compare here traditional relational database, traditional non-relational database, and a schema. So Cloud Spanner also you require a schema, and traditional relational database also require a schema. It also supports SQL, Traditional also supports SQL. It also supports consistency, very strong, and traditional is also very strong. Availability is very high, but it traditional, if your data volume is very high, then it can be failover. And scalability is horizontal, since it's a kind of the big data tools. So it's about horizontal scaling. Relational database support only vertical scaling. Replication is automatic and configurable. So this is the things. This is a diagram for cloud spanner, similar to big table. It's a similar to big tables. So, and here is some example cloud spanner tables and how the data will store. It's a similar to RDBMS. So please like and subscribe my channel. Thank you for watching.